Well, we are going to talk about the principle of potentiometer. Before that, let's have a look at what do you mean by a potentiometer and what is the use of it, right? Potentiometer is a device useful to compare EMFs of two cells. Two different cells are given for you. You want to compare the potentials, EMFs. How much is that? You can do that using a potentiometer. You can also find internal resistance of a cell. If a cell is given for you, what is its internal resistance is? We can find out using potentiometer. Anyway, you can compare the EMFs of two cells using a voltmeter too. Voltmeter also can do this job. Then, why shall we use potentiometer over the voltmeter? Why shall we prefer potentiometer over the voltmeter? Because of one simple reason, that voltmeter, while measuring EMF of a cell, draws some current from the circuit, from that cell itself. So the reading that what you are going to get is not going to be draws some current from the circuit. Therefore, the reading that we are going to get is not going to be accurate. It will have some error. Whereas in the case of potentiometer, it won't draw. Potentiometer won't draw. Potentiometer won't draw any of the current from the device whose EMF you are willing to calculate. Therefore, the reading is more accurate when compared with a voltmeter. Therefore, if you are preferring to have a perfect reading rather than having a very small error, of course, voltmeter reading error is going to be small, but even if you don't want that small error also, you shall prefer using a potentiometer. Fine. Then, on what principle this potentiometer works? That's the point that we would like to talk now. What is the principle of the potentiometer? The principle is simple. It says that the potential drop across the wire is directly proportional to length of that wire. How do you get this principle? It's actually very simple. It can be drawn basing on the Ohm's law itself. You know Ohm's law? Potential drop across a wire is directly proportional to current. To eliminate a proportionality, we put a constant resistance. We know that, right? So, if somebody say, if a constant current is passed through a wire, so we will make sure that current passed is a constant through wire. Then this I becomes constant. Then potential drop is directly proportional to resistance. But we know the resistance of a wire further is directly proportional to length of the wire, inversely proportional to area of the cross section. To eliminate these two proportionalities, we put a constant called rho, which is called as specific resistance. Specific resistance depends on the nature of a material and remains constant. So in the place of this R, I can substitute this value. So potential drop across a wire is directly proportional to rho L by A. But if you choose a wire with constant area of cross section, that means this area is constant. And of course, for a given wire, rho is constant anyway. I need not fix it. It depends on the nature of the material. For a given wire, it is constant. So, when this term and this term becomes constant, it's obvious that potential drop across a wire is directly proportional to the length of the wire, right? It's only, say, core principle. How do you implement it in potentiometer? I will discuss it in the next video. So this is just a introductory part of a potentiometer, that why a potentiometer over voltmeter. The rule is simple. Potentiometer won't draw any current from the circuit, therefore it is not having any error in the measurement. And the basic principle is potentiometer's potential drop across any wire is directly proportional to the length of the wire. How do you implement it in the device? I will be letting you know in the next video. Thank you for watching.